The shortened Bayes theorem tells us that the probability of B given A is equal to the probability of B times the probability of A given B over the probability of B times the probability of A given B plus the probability of B complement times the probability of A given B complement. This denominator comes from the fact that the probability of A can be expressed as the probability of B intersect A plus the probability of B complement intersect A, which is equivalent to P of B times the P of A given B plus the probability of B complement times P of A given B complement. This can be done because B and B complement partition the sample space, meaning that B and B complement have no overlap and that together they comprise the entire sample space. In the context of other problems, we can use different partitions of the sample space. If there were three events, T1, T2, and T3, that were all mutually exclusive, and their union was the entire sample space, then we could say that the probability of T1 given A was equal to the probability of T1 multiplied by the probability of A given T1 divided by the probability of T1 times the probability of A given T1 plus the probability of T2 times the probability of A given T2 plus the probability of T3 times the probability of A given T3. In general, if the events E1 through En partition the sample space, then the probability of some event Ei given A can be expressed as the probability of that Ei times the probability of A given Ei divided by the probability of E1 times the probability of A given E1 plus the probability of E2 times the probability of A given E2 and on until we have the probability of En times the probability of A given En. This can be called the expanded Bayes theorem.